Hi! Our project is an explorable explanation, which aims to help a viewer understand raycasting in video games. Unlike our previous project, this one is not data-driven, but rather attempts to take a viewer through the steps and concepts of creating a 2D raycaster to render a 3D environment. We start with a general overview of raycasting to give our viewers some context, but quickly dive into our application. Because of our project's methodical nature, we elected to use a scroll story to display different sections. The user will be able to view each step separately and move at their own pace. Additionally, they will be able to use the side navigation bar to take themselves to any point of the project. Each page will cover a major step in the creation of our raycaster, but we also included back and next buttons to help facilitate this navigation and allow a user to walk through each step in more granularity. This is because even though we have different pages, there are still a lot of steps and a lot of reading we don't want to overwhelm our users with at one time. We also made sure to make our raycasting visualization completely interactive. We felt that giving a user the ability to play around with and interact with intermediate steps of our project greatly assists in helping our users understand the topic. Users will be given instructions on how to interact with their visualizations, and upon interaction, our visualizations will be updated in real time. Though the methods of interaction change, depending on what method will allow the user to best understand the concept we have just introduced. We also include sliders that automatically update the raycaster's fields. We hope that through this visualization, users will be able to directly see how a certain field relates to and modifies the raycaster. Our 2D raycaster is eventually going to grow up and be its own 3D rendered world, which is the most complex step of our project. So for our last major form of explanatory visualization, we include animations to help highlight some of these more complex rendering tasks. Then, once our raycaster can render a 3D scene, we move on to more video game-centric topics.
Here, we are focused on building a maze iteratively to give users an interactive application of raycasters. The first couple visuals allow the user to add blocks and textures. This hands-on approach allows them to not only gain a better understanding of raycasting, but also shows how easy it can be to create a unique game environment using raycasting. The final visual is a finished game that leverages the preceding raycast concepts.